So we want to prove the integral from a to b x dx is equal to b squared minus a squared over 2. So by definition, this means limit n approaches to infinity. And if you use the right hand point, we get function is equal to a plus delta xi, right? Times by delta x. Now delta x is equal to b minus a over n. So we get b minus a over n I, b minus a over n. Okay, so let's plug this into the actual function. Right. And the function is actually just x. So you just, all we have to do is erase the f. Okay, next let's do distribution. So a times b minus a over n plus b minus a squared over n squared I. Now this can be expressed as sigma a b minus a over n. So I can actually do distribution, right? You know, with the sigma too, right? Like this. So if you have a function that's constant here, it's not dependent on I at all, right? Then what is it going to equal to? It's just this thing times by n, right? So remember sigma I is equal to 1 to n times c, it's c n, right? So it's going to be this times n. So n will disappear. So we're still doing limit. Here, we can actually pull out the b minus a over, b minus a over n squared in front of the sigma, and we can use a formula for this one. So we have a times b minus a and it's n plus 1 all over 2, right? This right here does not depend on n at all, so you can just bring it out to the front. Okay. The b minus a squared you can also bring it out to the front. And we only need to limit on, you know, this part. Actually, in fact, you can pull out the 2 at the front too. Okay. So what we have left over is n plus 1 all over n squared. And if I expand this, the top I get n squared plus n, and you can see that the limit is going to approach 1, right? The highest part on the top is n squared, and the coefficient in front of it is 1. The bottom is also, you know, n squared. So if you divide top and bottom by n squared, the limit will approach 1. So in the end, we have this. Okay? Let's expand that. ab minus a squared. And we have b squared minus 2ab plus a squared all over 4. Sorry, not 4, 2. Why? I don't know. I changed this to have the bracket on the whole thing. I should just have it on the top. Common base of 2, and we get 2ab minus 2a squared. So that's gone. Not only is it that gone, you can collect the a's and you get b squared minus a squared all over 2. So we're done the proof.